Question 1 from Section 2 of the 2023 Higher Physics Examination from the SQA. A van is travelling along a straight, level road at a constant speed of 13.4 metres per second as it approaches a set of traffic lights. The driver sees the lights change to red and applies the brakes. The van has a constant acceleration of minus 2.85 metres per second every second before coming to a rest at the traffic lights. And for 3 marks, we're asked to calculate the distance travelled by the van during the braking. Well, to start off with, we put down all our kinematics variables. In this case, we're going to put down u, the initial velocity, v, the final velocity, a is going to be the acceleration, S is going to be the displacement during that particular movement, and T is going to be the time involved. And we just search the data and fill in what we've got. The van is travelling with an initial speed of 13.4, so that goes in there, 13.4 metres per second. The final velocity has to be 0 because it came to a rest, so that's going to be 0 in there. The acceleration is a negative acceleration because after all it's coming to a rest, and that's given a value of minus 2.85 metres per second every second. And our job is to find that displacement which we're looking for. So we have 3 out of the 4 variables here. So we have u, we have v, we have a, and we have to have s in order to find it. So we look up our relationship sheets and we end up with the following equation. We end up with v squared is going to equal to u squared plus 2 times acceleration times the displacement. Now, a hint here, be organised, be well prepared, rearrange that equation so you can find the displacement s, and to do that we have to be well versed in saying that v squared minus u squared is going to equal to 2 times acceleration times displacement. So to find the displacement, you've got to divide that side by 2a. Now this should be well rehearsed, so v squared minus u squared, put a bracket around that to show it's the same number, or the one number, and divide that by 2 times the acceleration. All we have to do is just put in our values. We're going to have 0, take away u squared, which is going to be 13.4 all squared, and divide that by 2 times acceleration, bracket, 2 times, and remember it's a negative acceleration, so it's going to be minus 2.85. And if you do that in your calculator, you end up with the answer of 31.5, a positive value, because when you do it in your calculator, the negative at the top cancels the negative at the bottom. So the car, or the van, took a distance of 31.5 metres to stop. Question 1, part B. Calculate the time taken for the van to come to rest during the braking. Once again, it's the kinematics variables we put down. We've got u, the initial velocity, v, the final velocity, a is the acceleration, uva, s is the displacement, and t is the time. And we already know that the initial velocity of the van is going to be 13.4 metres. We did that in the previous part of the question. The final velocity is going to be 0. The acceleration is going to be minus 2.85 metres per second every second. We know that the distance in which the van took to come to rest was going to be a value of 31.5, so we can put that down if we want as well. But we're really after the time it takes for that van to go from 13.4 metres per second to a rest in a certain time, and we know it's acceleration. So we've got a complete choice here. We've got u, v, a, s, and we have to find t. But you go route 1, you go the simple one. We've got u, we've got v, we've got a, and why don't we use the t one here? And we can see we have the equation v equals u plus a t. Now once again, I'm a great believer of rearranging, getting proficient at rearranging. So we've got final velocity minus initial velocity, put a bracket around that, has got to equal to at. Just taking the u over the other side. To find t on its own, we have to divide by the acceleration both sides, and we've got v minus u on this side, divided by a, and that's going to give us a value of t. So there we have it. So we put in the values for the final velocity, which is going to be 0, put a bracket there, take away 13.4, we're dividing that by the acceleration, which is minus 2.85, and then 4, we just put into the calculator, and out comes 4.5 4.70 seconds. Keep it to the 3 significant figures as we've kept all the way through our calculations. So the van takes 4.70 seconds to come to a halt. Question 1, Part C. Complete the sketch graph of velocity against time for the van's motion during braking. And for 2 marks we're asked to put numerical values on both axes. You can see we've got the velocity axis and we've got the time axis there. We've also got all our information from the previous parts of the question. We've got the initial velocity 13.4, the final velocity 0, and it took a time for that to happen of 4.70 seconds. So we've got all the data there then. So we start with the initial velocity, so we can put that to a point up here, say, and that's going to be 13.4. There's your value for that, 13.4. And then when we get to a time of 4.70 seconds, we'll just call that here 4.70 seconds. Then we have the graph made up for us, because all we have to do is just draw a straight line. So we start at 13.4 and that's us down there to here, and that's the final velocity equal to 0. So you can see the graph is a straight line. It's a negative gradient which goes along with our acceleration, minus 2.85. That will be the value of that gradient, minus 2.85. So that's it. That's the graph drawn. You can see the graph shows you the picture of what's happening. Now for extra marks, which is not in the exam, could you work out the area under that graph and then see what that's equal to? And we all know that the area under a velocity time graph should equal the displacement. So try it out for that wee bit extra revision.